Okay, so we're going to see more examples of of inductive predicates, namely the logical symbols themselves. So the connectives, the quantifiers, and even the truth values, false and true. So what we're going to do is basically look into Lean's internals, right? Because Lean is largely built using itself, using its own language. So here I've replicated the official definition. So we're not looking at the official thing, but they look very much like this. So you see when we had the introduction rule for AND, it was actually the first and only introduction rule of the inductive predicate called AND that has two parameters here. And you see, so it takes an A, so a proof of AND, of a conjunction, takes a proof of A, a proof of B, and that gives a proof of AND of AB. And of course, there's syntactic sugar, right? So the AB here is not shown because it's a parameter here on the left-hand side of the column. But what we end up writing later is this, right? But first we define AND AB, and then we introduce the sugar. But here we don't care about the sugar. We just show the ASCII version, right? So this is AND. For OR, there are two constructors. So it's like if you have a proof of A, you have a proof of OR. If you have a proof of B, you have a proof of OR. For if and only if, you just have one introduction rule. You need a proof that A implies B and a proof that B implies A. Right here, you have only one intro rule, which we've seen before for exists. For true, we have one intro rule, and for false, we have zero, right? So there's simply no way to create a proof of false, or at least we hope so. At least no official way here, right? Because there is simply no constructor or no introduction rule, which is the same by Curie-Howard. And equality is just reflexivity. That's the only property we need here. So we say that for any value, the value is equal to itself, and that's how equality is defined as the smallest predicate that satisfies that. So here I'm showing this just for illumination, but I know from previous years that sometimes some students get confused because when you look for an example of an active predicate, I would suggest not to look at these because these are not typical. They're not. When you're going to use Lean, you're not going to define AND and OR. They already exist. So this is really showing you the buildup of Lean, and also help you understand a bit better how the connectives work. How to reason about them, and why we can do certain things with them, and also in the other direction. So what you've learned to do with the connectives, you can now apply to even, to tennis game scores, to other transition systems, reflexive transitive closure, and so on. So it goes both ways. So I think this little section here should be more helpful than confusing. So don't let it confuse you. These are not typical things. They're part of the buildup of Lean. And that was its very short segment now.